This is AASHTO's procedure T272, one-point method for determining maximum dry density and optimal moisture content. This procedure shows us how to obtain a rapid determination of the optimum moisture and maximum dry density of a soil sample by only pounding one point of a proctor, instead of developing a full proctor curve. The result of a one point can be compared to either a single reference curve or to a family of curves to determine optimum moisture and maximum dry density. If we are going to compare the results of a one point to a single proctor curve, then we must use the same proctor method to pound the one point as was used to develop the reference proctor curve. In addition, we have to have the same soil classification of the material that's used to pound the one point as was the soil classification that was used to develop the reference curve. The moisture content of the one point specimen must be within 80 to 100% of the optimal moisture for the proctor curve that's being referenced, and the dry density of the one point specimen must fall within plus or minus 2 pounds per cubic foot of the proctor curve being referenced. If both of these criteria are met, then the maximum dry density and optimal moisture content of the reference curve can be used as a close approximation for the maximum dry density and optimal moisture content for the one point. So, this is an example of how to compare a one point to a single reference curve and to obtain maximum dry density and optimal moisture content. So we have a reference curve here that was pounded with a dry density, a maximum dry density of 114.7 pounds per cubic foot and an optimal moisture content of 11.2%. So if we pound a one point, and again using the same proctor method that was used to develop this reference curve and the same soil classification, and we pound a one point, and we get a density result of 114.3 pounds per cubic foot and a moisture content of 10.3%, we then have to plot this one point on the graph, and we then have to compare it to the reference curve to see that the criteria is met. So the first criteria is, are we within 2 pounds per cubic foot of the reference curve? So we take our density of our one point, 114.3 pounds per cubic foot, and then we draw a vertical line down to the reference curve. And we see on the reference curve we are at 113.1, 2, 3, 4, approximately 5. So 114.3 minus 113.5, that is within 2 pounds per cubic foot. Next, we need to make sure that we are within 80 to 100% of optimal moisture content. Our moisture content for our one point is 10.3. Our optimal moisture content is 11.2. So we take 80% of that, 0.8 times 11.2%. That equals 9.0%. We plot that on the curve, on the reference curve, and our one point does fall within 80 to 100% of moisture content. So the one point does fall within 2 pounds per cubic foot of the existing curve's dry density, and it also falls within 80 to 100% of optimal moisture content. So this one point can be used with this single reference curve. We then approximate that the maximum dry density for the one point is close enough to 114.7 pounds per cubic foot, and the optimal moisture is close enough to 11.2%. Now we will look at comparing the results of a one point to a family of curves. Again, we must use the same proctor method to pound the one point as was used to develop the family of curves. So if all of the curves on the family of curves were pounded using a T99A or a T99C, then the one point must also be pounded with T99A or a T99C, etc. The soil classification for the material used to pound the 1 point must match the soil classification as was used for the materials to develop the family of curves. The moisture content of the 1 point specimen must be within 80 to 100%. In other words, the 1 point must plot within the zone created between the spine and the 80% line of the family of curves. If the moisture of the 1 point falls outside of this zone, we can plot a second point after we adjust the moisture content of the material and pound it, and then we plot that on the family of curves. If the second point reveals a curve that will not match the trend of the curves in the family, then we must develop a full moisture density curve to obtain maximum dry density and optimal moisture content. When we plot our 1 point within the family of curves, and those criteria are met, if the 1 point falls on the limb of an existing curve in the family, we use that curve's optimal moisture content and maximum dry density for the 1 point. If the 1 point falls between two curves in the family, then a new curve is drawn parallel to the closest curve in the family. The optimal moisture content and maximum dry density of the 1 point is taken where the newly drawn curve intersects with the spine of the family of curves. We will show you an example now. In front of you is a family of curves, and we're going to give you several 1 point results and show you how this criteria is met and how we obtain maximum dry density and optimal moisture. The first 1 point result we're going to look at, we have a density of 115.8 pounds per cubic foot and a moisture content of 14.4%. We plot that on the family of curves. Again, our moisture needs to be within 80 to 100% of optimal moisture content. This 1 point plots to the wet side of the spine, so we are above 100% of optimal moisture content. So we cannot use the family of curves with this 1 point result. Second 1 point result, 113.0 pounds per cubic foot and a moisture content of 10.6%. We plot this on the family of curves and we see that we are too dry. We are below 80% of optimal moisture content. So again, we cannot use the family of curves with this 1 point data. The last example will 1 point result with density of 116.4 pounds per cubic foot and a moisture content of 11.2%. We plot that on the family and we are within 80 to 100%. It did not land on a curve, so what we will do is draw a new curve parallel to the closest curve in the family. And to get the maximum dry density and optimal moisture content, where our newly drawn curve intersects with the spine of the family, we then derive our maximum dry density is approximately 118.5 pounds per cubic foot, and our optimal moisture content for this 1 point is approximately 12.9%. This is how you plot a 1 point result on a single reference curve and on a family of curves. You will be expected to do both of these procedures in your practical examinations when you come in to certify.